Let us consider one more numerical based upon Wheatstone's network. In this numerical, R1 is given as 5 ohm, R2 is equal to 10 ohm, R3 is equal to 15 ohm and R4 is equal to 60 ohm. Once again, these four resistors are connected in the form of a quadrilateral so as to form a Wheatstone's network. Now again we have to check whether it is balanced or imbalanced network. If it is imbalanced, then what shunt should be connected or must be connected with 60 ohm resistance to balance it. Now shunt always stands for resistance in parallel. You have to remember. Detailed idea about this shunt word we will consider in next article, that is galvanometer. So which we will discuss later. Time being, just remember shunt means always resistance in parallel. Now first of all we will check whether it is balanced or imbalanced network. So as per usual condition, we know that for balanced network R1 upon R2 must be equal to R3 upon R4. So we will check first of all this condition. So as per given values, first of all find out R1 upon R2. What will be this ratio? So 5 by 10. So is it 1 by 2? Yes. Now next R3 and R4. R3 is known, R4 is known. Substitute these values. So 15 divided by 60. So that ratio is 1 by 4. So from these two equations, equation first and equation second, it is clear that R1 upon R2 is not equal to R3 upon R4. What it implies? Network is imbalanced. Now to balance it, what to do? We have to connect certain resistance in parallel with this. This is already given. Sometime whether series is required or parallel is required, you have to check. Now here definitely parallel will be required because clearly mentioned what shunt must be required. So first of all we will assume in the fourth gap resistance required for balancing network be R4 dash. No doubt. Time being it is 60 ohm R4. But to balance this network, suppose this resistance is changed, it is removed and another resistance say R4 dash is connected for which this network is balanced. If fourth resistance is replaced by R4 dash, if network is balanced, we can use, yes, using balance equation. What is balance equation? R1 upon R2 is equal to R3 upon R4. So here we have to consider as R4 dash because we replace it. So by knowing R1, R2, R3, we can calculate R4 dash. So R4 dash will be equal to, yes, R2, R3. Now R2 and R3, so 10 into 15 divided by R1. So R1 is 5. So 5 3s are, so it should be 30 ohm. Means in fourth gap, we should have resistance, yes, 30 ohm, so that this network will be balanced. But time being, there is 60 ohm. So it is clear that 60 ohm value should be reduced to 30 ohm, and for reduction always parallel combination is preferred. In previous numerical we consider, yes, series combination. Certain resistance must be connected in series. In previous problem there was 20 ohm resistance. So we connected 10 ohm so as to get a desired value of 30 ohm. Now here desired value is 30 ohm and present value is 60 ohm. So it should be, yes, decrease. Now how to decrease? By means of parallel arrangement. Now suppose in order to get R4 dash, with this R4 certain resistance is connected in parallel. You just remember. This parallel resistance generally called as a shunt, denoted with symbol S. When this shunt is connected, as network is balanced, means equivalent of these two. Which two? R4 is there. How much is R4? 60 ohm. S is required. So result of these two must be R4 dash. How much is R4 dash? Just we calculated as 30 ohm. And we know that when these two are in parallel, using law of parallel combination, 1 upon Rp is equal to 1 upon R1 plus 1 upon R2. Now here Rp equivalent must be R4 dash. So 1 upon R4 dash must be equal to 1 upon R1. R1 is present value. How much is? 60 ohm. Plus 1 by S. Now here R4 dash is 30 ohm. So we can write here 1 upon S is equal to 1 by 30 minus 1 by 60. Now taking LCM, so 1 by S is equal to 60 minus 30, so that is 30 divided by 30 into 60. So 1 0 will be cancelled, 3 2s are. So that will be equal to, yes, how much? Is it correct calculation? 60 minus 30. So this is equal to 30 divided by 60 into 30. Now 3 to the, so 3 to the 60. So 1 by S 60. Now 1 by S is equal to 1 by 60, and hence we will get shunt resistance required. S is equal to, taking reciprocal, S is equal to 60 ohm. Is it clear? It means that in order to balance this network with the 60 ohm resistance, shunt resistance of 60 ohm must be connected. And we know that 60 parallel 60 result is always 30. So in order to balance this network, shunt required with this fourth resistance, that is 60 ohm, is also equal to 60 ohm. So this is detailed idea how to solve numerical based upon Wheatstone's network. These are only two possibilities. Network, if it is balanced, there is no question. But if it is imbalanced, then with fourth gap resistance, not always fourth gap, sometimes third gap resistance may be modified. So depend. As per this statement, you have to check what combination is desired. Sometimes that particular resistance must be increased or that resistance must be decreased. In order to increase the resistance, always prefer series combination. To decrease the resistance, preferred parallel combination, which is also called as a shunting. And resistance in parallel is also called as a shunt resistance. So this is little idea to solve numerical based upon Wheatstone's network. Now in next video we will consider how to solve numerical based upon meter bridge, specifically to calculate unknown resistance of given metallic wire, and second one, unknown resistance of a given galvanometer. Okay, thank you.